First, introduce the accessories of the pipeline instrument. This is the transmitter, receiver, direct connection line, the connection line with the transmitter, the connection line with the receiver, the ground line, the charging line, the converter, a transmitting clamp, a receiving clamp, a ground pin. This is in a frame for measuring ground leakage faults. The two ground pins are connected to the frame. Let's introduce the functions of the pipeline instrument. 1. Cable path location in the state of power outage or LIV. 2. Identify cable under state of power outage or LIV. 3. Find the fault of low resistance cable to ground leakage. Insert the direct input wire into the transmitter interface. The red wire clip is connected to the phase core of the cable. The end of the phase core must be artificially grounded, and the black wire is clipped to the field ground. After the wiring is completed, power on, backlight, low frequency, low gear, direct connection. Below is the automatic impedance matching. After the frame logo is rotated, the transmitter operates normally. The frequency knob can be adjusted: low, mid and high frequency, radio frequency. Generally we use low frequency. Adjust power: mid, high, low. The direct connection method is to plug in what line, and it will be displayed directly on the screen. Now, after normal operation, it shows 3 ohms, and the signal effect is good. The transmitter parameters are adjusted. Turn on the receiver, open backlight, and start to do a calibration. 2 or 3 meters away from the transmitter, just above the cable, perform a calibration comparison. Backlight, current, frequency, displayed in the upper right corner of the screen. It must be consistent with the frequency of the transmitter. This is a low frequency, and the transmitter must also be a low frequency. Gain adjustment, displayed on the upper left of the screen. Sound. Select modes: peak method, valley method, or frame method. In general pathfinding, using the peak method, its sound and energy bar display will be more obvious. First, calibrate at 2 or 3 meters far from the cable head. The gain may be too large, so it needs to be reduced. The purpose is to make the sound and value maximum when it is directly above the cable, and the value will decrease when it deviates from the cable. This will allow you to distinguish between 1 or 2 signal changes directly above the cable. When the receiver is directly above the cable, it is loudest, and away from the cable, the sound decreases, indicating a good calibration. The resistance value we simulate is too small, and the energy value always reaches the full 999. Generally, it is not necessary to reach 999. More than 800 is okay. When we look for the cable path, it is in this area that it has the most energy. After the adjustment, keep the gain value unchanged. Listen to the sound and energy changes, and keep moving forward. Just swing left and right along the path with the loudest sound. If there is a turning point, rotate to find the direction with the largest energy signal and continue to move forward. The ground pin, stab into the ground, and the black wire of the direct connection line can be connected to the ground pin.